Hi, and welcome to Security for Video Delivery. I'm Ernest Russell with Product Marketing for Limelight, and I'm joined by Charlie Kraus, who's also in Product Marketing. Today we'll cover Security for Video Delivery. If been following our series, our bit by bit series, you've seen we've talked about live video delivery and video on demand, and also optimizing your video storage. And you can go back and enjoy those episodes in any order if you're interested in those topics. Okay, so here in episode 5, Security for Video Delivery, we'll talk about some cyber attack data and why you really need video security. We'll talk about some of the challenges around video security. Talk about some DDoS protection, some web application firewall to protect your web apps from attacks, and also bot management, good bots and bad bots. And also, we'll cover some additional video protection, like SSL, to make sure that you're delivering your video securely. So, why do we need to protect our video? There's also not just the video, there's sensitive data that can be communicated across the network. And 45% of organizations last year suffered a data breach. And so even something as simple as when you're having a USB in your network that someone can transfer files to, you want to protect that data. And so 28% of companies name data theft as the number one security challenge. And so it's definitely a top concern, and 26% see data protection as their top security concern. And so we'll show you some ways to protect your video, and again, not just your video, but sensitive data traveling over the network. Because when customers have a breach, they lose trust. Right, and 30% of customers will take action after a breach, like ask for compensation, leave, or even sue. And so we'll talk about protecting your video in several different layers. One is the cloud security layer, where we'll talk about, again, distributed DOS attacks or distributed denial of service attacks, and also web application firewall. We'll talk about bot management, and again, why you want to allow certain bots and why you don't want to allow others, and also more security that's more specific to video security, like DRM protection, digital rights management. We'll talk about how SSL encryption is important in protecting your video, and also geolocation and tokenization. Now, I'll hand off to Charlie to talk more about the challenges with protecting your video.
Hi, everyone. This is Charlie. So I put the challenges sort of in 3 major buckets here. So one is just large-scale attacks, denial of service attacks. So one of the main challenges just over the last years, the size, the sophistication, duration, frequency, all have increased. We're up now where some of the bigger attacks are getting over a terabits per second in size. And some even last a long time. We've seen where there's large attacks and the duration goes over days. It's not just like an hour event, but it can actually go on for days. And then frequency, if it works, then they try it again. It's a big problem. And a lot of these are, distractions. So sometimes the attack isn't really necessarily to bring a site down, but they do that. And while the IT people are scrambling to solve that challenge, they do something else, like do a web app attack to steal data. So sometimes, what cyber criminals do is they'll do a distraction, and then while you're paying attention to that, do what they're really after. So they're really getting, fancy about this stuff. Now, when you're detecting, one thing you don't want to do is have these security measures impact your performance. You still want your website to be operating at full capacity all the time. So what we're going to talk about is how you can have an effective way to detect and block these attacks, but not impact your website. And a lot of it has to do with the way you're doing monitoring and the way you do scrubbing and so forth. And we'll talk about that. And then there's scrubbing. When you find an attack, you want to scrub the bad traffic. And the best way to do that is having both scrubbing centers and detection centers co-located in the same regions or the same POPs around the world. If you have to detect bad traffic and then send them off network to a remote site to do the scrubbing and back, that adds latency to the process. So it slows down getting the real good traffic back and then forwarded. And again, you don't want to impact your performance that way. So fortunately, all these issues can be solved very handily. So let's get into this. So it's not just your websites. So you think of DDoS attacking your web infrastructure. You got to consider this in three ways today. So certainly protecting the website, both keeping it up and running by preventing DDoS attacks, protecting the apps that are running in there. But mobile is huge. You know, the most prominent way people play games today, watch video online and so forth, it tends to be on mobile. So it's become very much a mobile first world out there. So you want to have equal protection for your mobile infrastructure and your apps. And of course, APIs. So again, DevOps, API use, huge increase in these ways of interacting with applications. So again, you want to protect that as well. So you want to go across all these channels in setting up your defense mechanisms. So let's talk about what does mitigation do? So a DDoS attack goal, it's always about making mission critical information unavailable. So that's done by using bots, which we'll talk about, and you get a lot of bots working in concert, and it looks like somebody's just doing a standard request for some information from a website, but they send so many of these requests that it clogs up your connection to the internet and actually prevents other people, like legitimate users, from actually getting at your site. So they're just trying to make it unavailable. So the way the mitigation works is it examines the type of traffic coming in compared to normal operations. So we call these signatures. So when you have a bot attack, there's a certain signature of that in the way the software directs them to attack you, and those signatures become well known. And so if they detect these signatures, that's how they detect it. And so when you detect that kind of traffic, it automatically redirects that traffic to a scrubbing center. And again, I mentioned that having that same scrubbing center in the same global POP as your detection makes it faster. So you can scrub the traffic, take out the bad traffic, and then good traffic is forwarded back and sent to the user. So the things you want to work on with DDoS attack protection, one is both speed and scale. So the ideal situation is to have detection nodes located globally. Call it a large defensive surface. You hear the term large attack surface. This is a large defensive surface. So around your POPs around the world, what you want is looking for a service that has detection globally. And then also you can tie this in with your DNS redirects, your DNS service that you use. So you can have protection also look at traffic as part of your DNS, so it sort of doubles the protection. So if you spread this around the world, it helps you scale so you can detect attacks sort of closer to their source and not try to detect them close to where they're destined, where the most traffic is aggregated. So if you can detect them out at the source of them, it's easier to detect it and scrub them and mitigate it. You want a lot of flexibility too about some organizations are more savvy about cybersecurity measures than others. Some have internal resources. But you want flexibility to have things either initiated by your organization about when you mitigate and when you don't, or you may just want it to be automatic, what we call always on. So your traffic is watched, and it's watched by basically intelligent algorithms. And you can say if it's always on and there's an attack, just stop it. Or you could say if you notice an attack, give me an alert, and then I'll have my people look at that and decide whether they want to block it or take other measures. So you like that flexibility. And expertise is important. It's a very challenging environment. It's very tough for people that aren't focused on security to keep up with the latest attack signatures, the countermeasures to stop them, and so forth. So having a partner that has security experts that are expert at this is always good to have. And being accompanied by professional services that will help you set up your security profiles and what you want to protect and watch over with you. So the way DOS mitigation works is you could have different types of attack. I made a diagram here showing application reflection attacks and different types of attacks, botnet attacks coming in. So at the edge of the content delivery network, so to the left of the cloud, that's where the detection nodes are. And so clean legitimate traffic is just on like the green arrow, just directly delivered right to the website. But any of the red traffic is going to be detected and it's going to be sent for scrubbing, and then the clean traffic will come back and deliver. So this is sort of a global picture of how, if you could imagine these little detection nodes dispersed all around the globe, this is how they work in concert with the scrubbing to keep the traffic clean. Now, what about web application attacks? So this type of attack is not looking to stop your traffic from coming in. What it's trying to do is extract information. It could be screen scraping of sensitive data. If it's a site, like with video, you have, if you're a video service, you have consumers coming in and you have their credit card information and other sensitive data. And what they're trying to do is get at that data and actually steal that private data, credit card information, social security numbers, etc. And so a web application firewall, it examines the traffic payloads and it looks at behavior. So web apps typically change a lot. There's always a lot of edits and update to your web application environment, and typically there's a lot of web applications. So it makes it very difficult to manually create application-specific rules for yourself. So the best way to do the protection is what almost all services use is security based on the Open Web Application Security Project, or OWASP. So this is a public service that all types of attacks and their signatures and how to detect them and so forth are kept up to date in that database. And you use that OWASP database to populate the rules in the WAF detection engines in the network. And that's just automatically happened for you. In addition to that, some applications that you build yourself will have their own vulnerabilities that you have to worry about. So you can have application-specific rules created. If there's only a few vulnerabilities, you could create the rules yourself, or you can use something called behavior analysis, and we're going to get into that. So here is a diagram showing the WAF traffic flow. Similar to DDoS, you have legitimate traffic that will just be passed right through. It'll be looked at, and it'll pass through if it's clean. If there's attack traffic, and that's usually in dynamic traffic. If you think of the web traffic coming in, it's always the dynamic traffic that is involved with attacks. So if you have non-dynamic traffic, you know it's legitimate and can pass through. If it's dynamic traffic, you're going to have it examined by the WAF nodes, and if the traffic is clean, it just passes it through. If it's not, it'll block the attacks and then filter them and send them through. So they're both quite similar. So best practices. Most WAF services use a negative security model. So what this means is you create rules that says pass everything except specific filters that I create. So one of them that they use is, as we mentioned, the OWASP top 10. And so they have that. But that can't protect from unknown vulnerabilities. If you've heard of this term, zero-day attacks, the zero-day attack is an attack that's never been seen before. It's a brand new created attack signature. And in a negative security model, you can't detect this because it's something you haven't seen. You won't have a rule set looking for that because it's new. So negative security model is only useful in terms of providing the top 10 OWASP because that's populated by a database, but it doesn't protect zero-day, and it doesn't protect your custom-built applications that have their own custom vulnerabilities. So what you want is both a negative and a positive security model. So a positive security model is quite different. You don't manually create rules. This is what I was mentioning before about behavioral-based rule. So it learns and defines what actions are legitimate. So this is great, especially if you have a large amount of web applications and they're changing very often. So when you deploy this, for the first few days of the deployment, it watches normal consumer or user legitimate traffic going to your web apps, and it looks at what that all looks like. So it basically does behavior modeling of what legitimate traffic looks like. And then once that starts building up and they have that good database, then it looks for things that are different. So when it sees something that doesn't look like the behavior models, that raises the flag that, aha, this is potentially an attack traffic, and then it's examined carefully. The advantage of this is this can block zero-day attacks, because a zero-day attack, again, it's a signature that's brand new, it hasn't been seen before. A behavioral analytic tool will say, I don't know what that is. So immediately it'll say, I'm going to block it because I've never seen that before. So that gives you protection from the zero-day attacks. So the best practice is to have a security solution that uses both negative and positive models. Now let's talk about bots. Not all bots are bad. In fact, the internet couldn't function without bots. So if you think about search engine crawling, Google, how are they able to direct you to content? Of course, they have these bots that go out and they look at websites and they crawl around and they look at all the content within them, documents, so forth, and they send all that information back to databases. So search engine crawling is perfect for this. Website health monitoring. So again, checking the performance and the health of websites. There's a lot of services that do that, and they do it with bots. They use bots for vulnerability scannings on applications. They look for ways that there's vulnerabilities that can be broken into and report that out so you can improve your filtering. So good bots are absolutely necessary. Now the bad bots are the ones that get involved with DDoS attacks, with website scraping, data theft, account takeover. There's so many types of these. They call inventory attacks. So for retail websites, what can happen is they fill shopping carts and abandon them, over and over and over again, so that it looks like inventory's down. So these are very nefarious. They're going on all the time. But the important message here is, if you can't tell the difference between good bots and bad bots, you don't know if you're under attack. The only way to know is to be able to differentiate between those two. So you need a bot management solution. So protecting your video. So besides these important services, there's some others that are typically part of most content delivery network services. One is digital rights management. So if you just have high value video content or you're licensing content, you'll often have to enforce sometimes geo restrictions or user restrictions or subscriber restrictions on what people can do with video content. Can they view it, only view it? Can they view it and record it? Can they share it? And so forth. DRM lets you have all these different settings for what users can do when they get a hold of video. And it's very important. One of the things that complicates DRM is there's not just one DRM scheme. There's multiples out there. There's the Microsoft Play Ready, Apple's Fair Play, there's Google DRM, etc. So you have to be able to support all of these. HTTPS, almost all traffic, video, everything is encrypted these days. So very important. And you want to be able to make sure that you have encryption on the scale of where you're sending. If you send traffic globally, you want global encryption capability. Geolocation, a lot of uses for this. Sometimes content has restrictions about viewer in a region. You think of sports blackouts, for example. You need to know where people are coming from so you can block. And good geolocation service will let you set, and it's very granular. You can set it, of course, on country-based. It could be state or province-based, down to cities, zip codes, even GPS coordinates. And the other thing that they do is they're aware of all the anonymizers out there. Because one of the things with like blackouts or people trying to get at data, if their country is blacked out or their region is blacked out, they use what's called an anonymizer that tries to disguise where you're coming from by picking an IP address that's in the region that you're coming from. But all of the anonymizers are well known, and that's part of the geolocation security, is that they recognize the location, the IP addresses of all these anonymizers and then can block them. Then tokenization is other various ways of protecting traffic. So sometimes it's time-based, where you set a token so that a piece of content's only viewed starting at time X to time Y, and then it's not available anymore. It can be just that you use it to restrict who can access to it they need a token to be able to decrypt the traffic. So there's a lot of options and flexibility in terms of how you use tokening, and it's all about access control and keeping things to legitimate authorized viewers. So in a summary here, let's go around and just pick up the highlights of what I said. So, so global detection and in-network scrubbing for fast detection is very, very important. You don't want to have an impact on the performance of your website while you're protecting it. Web application protection is critical because data theft and the fact that your applications change a lot, there's a lot of them, and you want to be able to have it automatically done. So a good WAF service that uses behavior modeling is the best practice. Keep unauthorized users out with the multiple access control measures we talked about. Protect high-value content with digital rights management. Manage good bots and block nefarious bots. Again, if you can't tell the difference between the two, you won't know if you're under attack. And just expertise. Make sure that the service you're looking at have expertise to back you up because it's complex, it's rapidly changing, and keeping ahead of the types of attacks and the way they're defended against, it's very hard to do by yourself. So I'm going to turn it over to Ernest to wrap up.
Wow, thanks, Charlie. It's a lot of information there, but you did a good job of giving our audience a good summary of some of the tools they can use to help protect their network and their video. And so we've covered meeting audience expectations. We've covered getting started with live video, also video on demand, optimizing your video storage, and now security for video delivery. So stay tuned for choosing the right CDN, and thank you for joining us here at Limelight.